Hello, now I'll talk about relative velocity. You can watch the lecture again, and it's easy now to deal with an example. If we have a boat and this boat is moving to the right with 5 meters per second inside the river with respect to the ground, this is the ground. Okay, it's a simple idea. And there's a person moving by 1 meter per second to the left. We need to assume or consider our directions. So this is the positive x, this is the positive y, this is the negative y, this is the negative x. The ground has a zero velocity with respect to itself. There's a person is moving to this direction. His name is 2, but this person is 1, has velocity v1. This person has a velocity v2 with respect to ground, which is equal to 3I minus 2j meters per second. Now we can put our velocities, if we like, and I need you to find the relative velocity between the first person and the second person. We have two directions, x and y, so we can work with x separately than the y direction, from the y direction. Okay, now I need v1, 2, v1 with respect to 2. It is, I can reach from 1 to 2 by considering the velocity of the first person with respect to boat, and the velocity of the boat with respect to the ground, and the velocity of the ground with respect to the second person. So I bridge 3 times from the first person to the boat, to the ground, then to the second person. So v12 is equal to, in x direction I'm talking now, v12 is equal to v1 with respect to boat plus v of the boat with respect to the ground, which is the river speed, and v of the ground with respect to the second person. We have, for the first person with respect to boat, his velocity is negative. It is to the negative, to the left direction, and there is zero component in y direction. Also, the velocity of the boat with respect to the ground is 5 meters per second to the right, and there is zero component in y direction. And the velocity of the ground to the second person with respect to the second person, it is negative of the velocity of the second person with respect to ground. So this is 3 minus 2, it will be minus 3 plus 2. This is the velocity of the second person with respect to the ground, which is the given one, which is 3 minus 2. 3I minus 2j. We need just to reverse it. Okay. Now, I need to find the velocity in x direction. Just, I use now the velocity vectors. v1b in x direction is minus 1. vbg is 5. This is 5. v, the ground, with respect to the second person is negative 3. The resultant velocity is positive 1. So the relative velocity between the first person and the second person is positive 1. So the distance between them is increasing because the velocity is positive in our notation here, because in our xy plane here. What about in y direction? In y direction we need to use the y components and just add them together. It is v1b, vbg, they are 0 0, and v ground with respect to that person, which is sorry, it is not plus 2, not minus 2, it is plus 2. So it is plus 2, the answer, ng. So the velocity vector, the relative velocity vector V relative from 1 to 2 is equal to 1 I hat plus 2 j hat. This is the relative velocity in 2 dimensions between two persons. And that's it.